In this video we're making a toy front loader. You can check the description for a link to a free SketchUp file with all the dimensions you could want. The thing is, I didn't just make one of these, I made 25. I did that so I could donate most of them to charity. So some of the techniques that I use aren't really applicable if you're just making one. So we'll talk about some of those differences as we go along. Because there are 23 separate parts that need to be made for this, I'm not going to show you every single step along the way. When you're designing a toy as opposed to a model, it's always going to be a compromise. What makes it even more complicated is because I'm going to be selling some of these, I have to comply with the law. And we have this law in the US now that requires third-party testing for lead and different things. But because there's an exemption for wood, I've made this model with no mechanical fasteners whatsoever. For the 2 layers of the frame, I'm using pine. And by the time you attach all the other parts onto this, that center part is pretty well protected. So I don't have a problem with using softwood here, and it saves a little bit of money. The axle holes are the same distance from the front and the back. So if your drill press can make that hole in one pass, then you don't have to move the stop at all. In my case, I have to drill it from both sides. I do 2 of them, and then move the stop and do the other 2. And it's important to keep the same face up against your fence while you do this. If I were only making one of these, or just a couple, I would make the rest of the cuts on these 2 pieces at the bandsaw. But those bandsaw cuts are going to be difficult to sand, so with the number that I'm making, I have a better way to go about it. With the blade in my table saw tilted to 45 degrees, and about 8 pieces clamped together, I could just run those against the fence. And again, these cuts are the same distance at both ends. It's almost like someone designed this to be easy. And then I remove the rest of the material at the router table. Both at the table saw and the router table, I have sacrificial pieces clamped on both ends to minimize the tear out on my workpieces. And then it's back to the table saw to cut the notches on the front. And we're basically making 10 in here, so I'm starting with the shoulder cut. And then to make the vertical cuts, I'm going back to clamping 8 pieces together again. And this cut was a little bit dodgy. By the time you make the second cut, you don't have very much to register the piece on. And I also had kickback of one of the off-cut pieces. So you might want to do these at the bandsaw. It's a lot safer. I did a little bit of sanding while the pieces were still clamped together, and then I could glue those 2 pieces together. Moving on to the cab, the first hole I'm going to drill is from the side, and that goes all the way through. And then I'll drill the hole to the front, and I want to do that second because drilling into the end grain is a lot more difficult. And the depth of that hole is right to the center line of the hole from the side. And you want to make sure that that piece is really clamped in tight from both sides, because it's really going to want to shake around. Then I can cut the angles for the front at the bandsaw. For what I'm calling the pivot blocks that the arms are going to attach to, it's a little tricky drawing that hole because the piece is so small. So I made a little holder to hold that against the fence and keep it from being able to rise up. The one that goes in the body also gets 2 holes that are going to hold my fake hydraulics. And in this case I didn't mind just flipping the piece around because the location isn't really that critical. The hydraulics are an 1/8 inch dowel going into a 3/8 dowel. So I need to make an 1/8 inch hole into that piece of dowel. To do that, I'm drilling a 3/8 hole into a piece of scrap, and then I can change to an 1/8 inch bit and put the dowel into the hole that I drilled, and the hole is going to be centered, assuming that your dowel is actually 3/8 of an inch. Which is a good time to point out that when you're drilling holes that dowels are supposed to go into, it's a good idea to measure your dowels first. Then it was time for some assembly, and the place where I wanted to use screws is where this front piece attaches into the body. Because if anything is likely to break, it's those 1/8 inch dowels. So I'd like that piece to be able to come off to be able to replace those. Because I can't, I'm using dowels instead. I can't just glue that onto the front of the body because it's end grain. Moving on to the bucket, most of the pieces are an 1/8 inch thick, except for the back, which is 1/4 of an inch. We're never going to see the edge of that piece, so we can cheat and make that thicker to improve the strength of our glue joints. The sides are a little tricky because they have 2 angle cuts. So first I cut those to length at an angle of 25 degrees. And I alternate back and forth between the miter saw and the table saw to do this. And then I did the cut at the top, which was at 15 degrees. And with those pieces cut, that establishes the height that the back needs to be. So I tilted the blade on the table saw and cut the back. You could also cut one edge of the top piece at 15 degrees. I chose not to do that. I think it's just as easy to sand it flush. Then I cut the bottom and the top to length. And then I used 2 pieces of scrap the same thickness as my sides as spacers against the stop to cut the back to length. The assembly of the bucket is a little tricky because of the angles and the pieces being so thin. So I like to do this in stages. First I glued the sides to the back. And I used some extra pieces that I cut to the same length as the backs as a spacer to keep the sides square. Then I could glue on the bottom, and I couldn't think of any other way to clamp this than to just use 2 of them and put a weight on top. And when that dried, I could do some sanding. Then you have to decide whether to glue on the pivot block first or the top. It's easier to sand the top with the pivot block out of the way, but it's more difficult to glue on the pivot block with the top in the way. So pick your poison. Then I glued in the wheels, and I used a piece of veneer as a spacer to give a little bit of play so the axle isn't so tight against the wheel, so the wheel can spin. Unfortunately, there's a lot of variation in the diameter of these axle pegs. The hole at the front is especially prone to splitting as it's so close to the edge. The one at the back, you can get away with it a little bit more, but you don't want to end up in a situation where the axle is almost all the way in, but it won't go in all the way. Don't ask me how I know. The ladder pieces are as simple as running a dado down the middle of a strip of wood. For the arms, you'll probably be using a bandsaw, but with 50 of them to make, I use my CNC. While I did lay out the pieces to avoid the nail holes in my pallet wood, I didn't bother working around the knots. I just made sure there were extras. I used the onion skin method to keep the pieces attached. And you want to be careful when you do that to use a down cut, because if, say there happens to be an upcut in your CNC and you don't feel like changing the bit, and you do it anyway, there's going to be some carnage. And for the final assembly of the bucket and arms, I made sure to put the glue in the hole in the arm, not on the dowel, and that way the glue got pushed to the outside. If you put it on the dowel, then it's going to get scraped off and end up inside of the joint and maybe keep your arm from being able to move. So I said I was donating most of these to charity. 4 of them are going to be for sale in my Etsy shop. It's a buy 1, give 5 deal. I will have the link to purchase those in the description. If you don't see the link, then they're already sold. It's a girl! Aw, she has your bucket.